So there's increasing evidence that exercise activity and exercise training actually not only enhances general fitness, but prevents and actually reduces the development of the complications of obesity, including diabetes. So we were interested in trying to determine whether we could identify factors that allow exercise training in muscle, and to see if they could be therapeutic targets in the long run for the prevention of the complications of obesity. Studies by our group and others have actually begun to look at the levels of this factor in muscle in humans, in health and disease. One study we did earlier on demonstrated that after exercise, the levels of PGC1 alpha and PGC1 beta, its relative, increase quite significantly in skeletal muscle in humans after exercise. And others have found that its levels are actually low in those who have developed insulin resistance, which is the first stage towards the development of diabetes. So we think that high levels of this factor could correlate with muscle fitness, and low levels could be linked to the development of insulin resistance and diabetes. We really wanted to do an experiment that would help us understand what it was in the obese state that leads to reduced exercise. And the only way we could really do that was to, if you will, uncouple or disassociate the obesity from the reduced exercise. And so when we removed this factor, PGC1, from the muscle of mice, they didn't actually develop obesity, but they still behaved, if you will, like a couch potato. They couldn't exercise on a treadmill. And so this is really interesting because the levels of PGC1 are actually reduced in obese people. And so we think this is part of the vicious cycle of reduced activity leading to greater obesity. We created really a couch potato mouse that wasn't obese but still had the complications of obesity, and that it really couldn't exercise very well. And this will be an outstanding model, a very valuable model for researchers in the field to further understand the link between reduced exercise capacity and the development of obesity. So it's also important to realize that there are many other disease states and conditions that would be enhanced by increased capacity for exercise. And that would include long-standing illnesses, recovery from long-standing illnesses or injuries in which a patient would be bedridden, and in many cases it's hard to get them back into physical shape, and so we believe that this approach might also be useful in that regard. There are many states in frailty and aging where we think this could end up being a very important chronic debilitating diseases, including cancer, for instance, often leads to reduced activity and another type of vicious cycle where muscle mass and bone strength is reduced, leading to fractures, etc. So we think it could be very useful in that scenario as well.